Dear students, today I will discuss with you some important MCQ from the chapter Solid. The first question is, in a hexagonal unit cell, calculate the unit cell constant. Calculate the unit cell constant, that is the number of particles present per unit cell, and it will be how much. Choices are 4, 6, 8, 10. So you see, for this there is an equation and a formula. This formula, like, what is the formula? For hexagonal, the z value is 1 nc divided by 6 plus nf, that is face, by 2 plus n adds by 3 plus interior by 1. So, but the calculation, we are not taking the adds. So, the z value is equal to 1/6 into 12 corners plus half into 2 faces plus 1 multiplied 3 edges. So you will get the answer is, it is 2 plus 1 plus 3. So your answer is 6. Okay. So B is the answer. Next, a compound formed by element A and B has a cubic structure in which A atoms are at the corners of the cube and B atoms are at the face centered. Derive the formula of the compound, and it is what? Okay. So you see, A atoms are present at the corners. So it is taken as cube. So A atoms at corners. So corner is shared with 8 corners. So you will get A. And it is B atoms are at the face centered. So face centered, one face, it is connected with 2 faces. On the face, the particle is shared with 2 faces. So 2 faces. Okay. So you have how many faces? 6 faces. In cubic, it is 6 faces. So you see now. You see, this is the cube. Okay. This is the cube. So this cube is having 6 faces. So 6 multiplied 2, it is B. So you will get 3B. So it is the ratio, A and B ratio is 1:3. So the formula is AB3. Okay. So the choice is C. Okay. Next, a cubic solid is made up of 2 elements, X and Y. Okay. Y are present at the corners of cube. Y are present at the corners. You see. Okay. And atoms X at the body centered. So Y corner, Y is at corner. Okay. So one corner shared by 8 corners. So you will get Y. Then body centered, and body is inside the crystal. So you will get what? X is present in the body. So the formula is X and Y. X and Y. So the choice A. So what is the question is given? What is the question is given? Centered. What is the formula of the compound? And what are the coordination number of X and Y? Again asking, what is the coordination number? So XY is the formula. So what is the coordination number? The coordination number is the coordination number is 8. Okay. The coordination number is 8 For this cubic, the coordination number is 8. So the answer is B. Okay, XY formula 8 is the coordination number. Next, an ionic compound made up of atoms A and B has face-centered cubic arrangement in which atom A are at the corners. So you see A at corner. So A at corner 1 by 8 multiplied 8 is equal to A. Then atom B are at the face centered. Atom B at the face centered. So for face centered it is distributed with 2. So for 1 it is half. 6 faces you will get 3. So B is 3. Okay. B are at the face centered. If one of the atom is missing from the corner, okay, one of the atom is missing from the corner. So 8, 1 by 8, okay, 1 by 8, one corner is missing, so 7, so we will get 7 by 8A. So B is 3B, A is 7 by 8A, so the ratio is 7 by 8 is to 3B, okay. So if we take it for whole number, then what will be the ratio? 7A is to 24B, okay. So 7 is to 24B, so you will get A and A7B24. So A7B24, it is the formula, okay. A7B24 is the formula. Do you understand? Next, a compound formed by elements X and Y crystallizes in the cubic structure where Y atoms are at the corners of the cube and X atoms are at the alternative faces. You see, it is very interesting. Okay, so Y atoms are at the corners. So for Y, it is corners. So 1 by 8 multiplied 8, you will get only Y. Then X atoms are the alternate faces. So for a cubic, see, this is the cube. For a cube, what are the alternate faces? For alternate two faces you will be get. For alternate face, okay, so you will get the only 2. So for face centered it is half multiplied for alternate face it is 2, so you will get 1. So your X is it is X. So again the answer is X and Y. Okay. So choice C is the correct answer. Choice C is the correct answer. Next, calculate the number of atoms in a cubic based unit cell having one atom on each corner. See, one atom on each corner and 2 atoms on each body's diagonal. Calculate the number of atoms in a cubic based unit cell having one atom at each corner. So corner you will get 1 by 8 multiplied 8, so it is 1, okay, and 2 atoms on each body diagonal. So for body diagonal you will get what? You see, for body diagonal, see, it is body diagonal. So in a cube, how many body diagonal you get? You see, from here to here it is 1, okay, then from here to here it is 1, the 2, then here to here another 1, okay, then here to here another 1. So 4 diagonals you will get. So in one diagonal you are taking 2, so for 4 it is 4 multiplied 2, so it is 8, and at corner you are getting 1 by 8 multiplied 8, you will get 1. So 8 plus 1, it is 9. So choice B is the correct answer. Do you understand? Next, a compound made up of elements A and B crystallize in the cubic structure. Atom A are present on the corners. You see, it is another compound A made up of element A and B crystallize the unit cubic structure. Atoms A are present in the corners. So A at corner. So 1 by 8 multiplied 8, you will get only 1 A. Okay, and corners as well as face centered. So far centered, A is also present face. So for face centered, half multiplied 6, you will get 3A. So how much? It is 4A. Next, B is present at the edge centered. B for edge centered. So how many edges are there? You see, how many edges are there? So you are having 12 edges. Okay, you are having 12 edges. You see here, how many edges are there in cubic? How many edges there? 1, 2, 3, 4. This side 4 and this side 4. Okay, it is 8. Then 1, 2, 3, 4. Okay, it is 4. The total edge is 12. So 12. One edge is shared with 4. So 12 edges you will get 3. And B are present at the edges centered as well as body centered. For body centered, it is 1 by 1. So it is 1. So it is also 4. So B is 4 and is 4. So the formula is A, B. Okay, the formula is A, B. Next, if 3 elements P, Q are crystallines in a cubic solid lattice with P atoms at the corner. Okay, P atoms corner. So 1 by 8 multiplied 8 is equal to P. You will get corner. And Q atoms are at the cube centered inside the center. So Q as body centered, Q is 1. Okay, then and R atoms are the center of the faces. R is center faces. So R half multiplied 6 faces. So 3R. So the formula is P, Q, R, 3. Okay, this is PQR3. Choice C is the correct answer. Next, sodium crystallizes in a body centered unit cell. Calculate the approximate number of unit cells in 9.2 grams of sodium. It is different. Okay, so you have to calculate. How you have to calculate? You see, the atomic mass of sodium is 23. So 23, that is 6.023 into 10 to the 23 number of atoms. Okay, then it is given 9.8 gram. So 6.023 multiplied 10 to the 23 divided 23 multiplied 9.2. So you will get how much? So this is your 0.4. So answer is, the answer you will get 4 3s are 12 and it is 9, then 0 and 24. Okay, So multiplied 10 to the power 23. Okay, 2.4092 multiplied 23. Okay, so but what is happening, each atom, that is in sodium chloride crystal BCC for body centered, half, okay, for BCC unit cell, calculus crystal approximate unit cell, the sodium crystal. Okay, so for body centered, this 8 corners are having 8, so 1 by 8 multiplied 8 is equal to 1. At the center of body it is another 1, so 2 atoms are present. Okay, so number of atoms present per unit cell, you are getting 2.4092 multiplied 10 to the 23 divided 2. So your answer, you will get 1.204 multiplied 10 to the 23. This is the answer. Okay students. Okay.